Hi, everyone. So yeah, my talk of today will be privacy protection in AI systems. I will start by just trying to converge to some definition of privacy. So privacy compared to other kind of technical principle that you want to integrate when you are designing any system, sometimes it can be hard to define for different reasons. So researchers have been trying to define privacy or ask people to define what privacy means for them. So there is a really well-known study by Professor Ulrich Aïvodji from CMU that she had a project called Privacy Illustrated, where basically she asked people to draw what privacy means for them. So it's two population, children and also adult people, asking them to just basically draw to see if there is some pattern emerging, something like that. So I will be presenting few examples. This one, for example, a person is saying privacy is I want to be alone when I'm in my bathroom. So this is the definition of privacy. Another is saying here that if people could read your thought, that will be creepy because they want to have some barrier protection around it. For this person, it's been unable to be identified. So you want to, when you are doing everyday activity, you want to people to not link what you are doing to your identity. For this person, it will be their life is a black box, and they basically have some specific window that they want to keep open so people to look at, but others should be closed. So it's also some definition of boundary of what you want to be visible, what you don't want to be visible. And for this person, is privacy is contextual, and it's a value that is important, but it's fundamentally contextual and universal. We can get back to what contextual means later. For this person, it's about control, controlling what is shared about your thoughts, your preference, the things that make you you. So basically, a control on how you want to be presented. So across all these examples, what is clear is that privacy is universal. And we also had privacy is mentioned in the Déclaration universelle des droits de l'homme, so Universal Declaration of Human Rights. We have a lot of regulation across all the many countries in the world that put privacy first. In Quebec, we have Loi 25 that basically has provision on how the data or privacy related things should be handled when we are designing a system that use user data, right, basically. We have GDPR in Europe. We had around many places in the world. We had we have different regulation around privacy. So these are just few examples. So when it comes to designing a system, people try to look at more specific properties when they're talking about privacy. So one of such properties is confidentiality. That means you want only authorized user or entity to have access to the data. So this is one definition of privacy. You also have anonymity, that is basically you want to be able to be, the user you should be able to hide someone in a larger group. So being anonymous is whenever you are doing online, people should not be able to pinpoint, but you should be easily, comment on dit ça, dissoudre dans la masse. Is that fine to everyone? Okay. So you also have linkability, that is another properties. That means if you are doing different activity, people should not be able to link all of them to you. For example, today to come here, maybe you use the public transportation and you have to badge. This is one record of yourself. Maybe later on you will go to, I don't know, cinema, or you will use different kind of services. Having a linkability is no one should be able to know that the same person that was taking this public transportation at this moment was the same one that was at other place, because otherwise people will have a huge quantity of data on you, and that is something we probably don't want. And you also have other definition of privacy, like plausible deniability. So plausible deniability is a nice property that you want to have when you are designing system to have privacy, because it gives people the ability to deny having achieved any action, right? When you are doing, for example, whistleblowing, if you want to encourage whistleblowing, you need to have this kind of property so people can feel free to speak without being identified. So this is a nice property to have in privacy. But in security, if you are designing a secure system, that you don't want to have plausible deniability, because in security you want to be able to trace everything that is happening in your system. So no one should be able to deny having achieved any action. So you can see sometimes when you are designing a system, you already have some conflict, right? Security is a nice property to have, but privacy also is another one. But sometimes the property can be in conflict. And the final property I will talk here is undetectability. That is a really strong property because you want the presence of absence of the user to be basically, you should not be able to say anything. So you observe an event and the user should be able to say that you should not be able to decide whether they were present or absent from the data you are observing on them. So this is a strong property that is used to also design a private system. So when do we use this property? We use them when we are designing any system where you have privacy in mind. So you can be to design communication system. It can be to do authentication, data publishing. So you collect a lot of data and you want to make them available for a new project, things like that. But for today's talk, we will focus on AI system, privacy in AI system. So I will be focusing on two main aspects on privacy in AI system. The first one is how interaction with your AI system will reveal things about your AI models. So here I mean the data that contribute to training your models. Sometimes they are private data, and this interaction. So the evil you're seeing here is someone that will interact with your AI system with the goal to learn as much as possible about your system. That could be data-specific information, so who was part of the training data, but it could also be model-specific information, like what kind of secret receipt you use to receipt you use to design the system, things like that. And but all these I will consider them in the category of interaction from outside, trying to learn things about your models. But we have another category that is you interacting with AI system with your data. You could also have some privacy issue. Basically, now every day, in your everyday activity, you are using ChatGPT or you are using other kind of chat interface or large language model, and you are doing so by sharing your data. And this is another part of the story. So you can think of you as a designer in an organization. Let's say you work at a bank. The bank had released AI models, so you will be on the first category. But you as everyday user using AI for different kind of activity, you will be in the second one. So in the first category, so we'll focus on different type of interaction, what they reveal about your data. And the first risk or attacks I will present is something known as membership inference attack. So anyone here is familiar with membership inference attack? Have you heard about it before? Okay. So let's say you train your AI system, right? You spend a lot of time and resource to do it, and you do that and by collecting different private data. And now you expose the AI system through API, and everyone can use the API to query your model to get some prediction. So the objective of the attacker in this setting is to learn whether a specific person in the population was part of the training data that used to train the model. So they are really not inside the organization. They are just interacting with your AI system by just querying it, but they can use this attack to learn who was part of your training data. So the information that the attacker learned here is 1 or 0, the person who was part of the training data. But what makes it very sensitive or privacy relevant for privacy is that the data or the model can be sensitive. Let's say we are in a healthcare domain that Quebec government decide to use all the data, all our data to build an AI system that you use to query to know, given my symptom, what kind of disease or what kind of basically learn things about your profile, right? So if someone is able to learn that you were part of the training data, they also learned that probably you were sick at some point and you contribute to the training data. So they learn information related to the user. And as we know here in Quebec, for example, we have Loi 25 that basically tell all organizations to make sure the data that you are using are protected. So here, this attack will basically create a privacy incident in the sense that we are learning more things about user data that we should not in the first place. Is that clear so far, the attacks? So how these attacks work is we have black box access to the model. Black box is just, you don't have any knowledge as attacker or what type of model is it. You just have ability to get the prediction, but you are still be able to learn this information. So what makes this attack useful or work is the fact that AI systems sometimes they had a different behavior on data they have seen during the training compared to data they have never seen in the training. So this overfitting kind of behavior is what the attacker will leverage here to do it. So I will keep the technical aspect very short, but the idea is you get the prediction of the models. One of the attacks, there are many implementations of these attacks, but one of the first one that was introduced would query the model, get the prediction, get the confidence of the models, and use it to learn if the user was basically present. Because the model will basically have more confidence on data they have seen, you can do this kind of statistical analysis to predict it. But there are many techniques that have been designed in the recent year that facilitate these attacks. So any questions so far? Want more detail on the attack? Yeah.
How would you protect your system from this kind of attack?
Great. We talked about the defense in a few slides, but let's say the most direct solution you can use here is to have better generalization, because if your model generalized well, they should not be able to have different behavior. They should perform equally well on all type of data, right? So this could reduce the information that you are sending to the attacker. So, but this does not have any formal guarantee that the attack should not work. Let's say the attacker have a stronger attack model, it could still work, even if you have good generalization. So there have been some theoretical solution that I will present shortly that try to address the problem. So most of the attack I will present today, sorry for you, we don't have solution, but this one has solution. But there are other that are still really open, and then research are still developing on how to deal with it. So the next attack is property inference attack. It's more a generalized version of the membership, where here the attacker goal is to learn any property of the training data of your models. So previously what we learned as property is whether this user was part of the training data, but you can learn any properties like how was the composition of the training data basically? Is it equally composed by male, female, or a user from a specific demographic group, things like that? You can learn all that by performing these attacks. And it's kind of the same principle, relying on the fact that the model will have a different behavior on data they have seen during the training, and a different behavior on data they have never seen in the training. So the attack will try to just leverage this difference to distinguish between presence or absence of the properties. So there has been a lot of work on this specific attack. The first that has been introduced look at speech recognition system, and they were able to predict that the user that contributed to the training data was from a specific region in India. So this is not something you observe through the API. You just have a prediction and get quick response, but you can still learn this kind of property that is nowhere present in the user interface, right? More recently, there has been another attack that they learned that the environment that contribute to the training has some security vulnerability. And this is also a really powerful attack, because now that you learn that, also basically the attack is a company designed a Bitcoin mining, right, detection. So you can install it on your laptop, and it will help you to know, given how your laptop is working, if someone is mining Bitcoin on your laptop, if you have a malware trying to do that. So to come up with this model, they need to have a lot of data themselves to do that. So they, for months in their own lab environment, they have been collecting different computing profile and whether or not there was mining activity. This gives a training data. Then basically what people learn through this attack is the specific environment where the data come from has some security vulnerability. because of how the pattern they have in the data is. So basically, they were able to do this statistical test to know the presence or absence of the property. So this is a really nice project, has been published as Usenist, one of the top security conference. So they just do this to show that, yes, sometimes the attacks that could, the risk that you are exposing your model to are really far beyond just the privacy issue, because here you are using this privacy attack to do a more powerful security attack, because knowing you have the vulnerability, you can just exploit the vulnerability in the second phase, right? But yeah, generally membership is just a generalization, and it works pretty much the same way we have the membership attack. I can give more detail if you want to learn how to do this shadow training strategy. So the next attack is data extraction. So data extraction attack is basically you also still have black box access to the models. That is, you can only query the model to get some input output. And here what you are doing is you are forcing the model to give you exact data they have in the training data. And this is a concrete example where you have a ChatGPT 2 that people just, you start a sentence, you ask the model to complete it, and they will complete it by using the data they have in the training set. So the idea of this attack is giving the models and any element of the training set, you want to find the prompt that when used for the model, it will release the data that is in the training set. So it has been recently implemented to show that large language model that production, like ChatGPT, Claude, they had books, they have memorized books that they should not be using in the first place. But this task has been used to show that, right? Basically, the way it works is they ask the models in the initial phase, you just start, but some paragraph in the books, and you ask the model to complete the sentence, and then they check if the models had match what was the original sentence in the first place, and then they move to the second stage where they repeat that until you get to the end of the book. And sometimes the model will refuse, and when it's refused, they use some jailbreaking strategy. They have many jailbreaking strategy. They will try n different jailbreaking, including paraphrasing, including using number instead of letter, things like that. So these are just all strategies you can use to force the model to respond. And at the end, they use the best of all these try. And yeah, they have shown that models like ChatGPT, Claude, they have pretty much memorized all the books. So this is another attack. So, and a concrete real world case where this was a privacy incident is a Liluda story. Have anyone hear about Liluda case here? So Liluda is a Korean startup, and they had one original project that was really a success story. That is, they had a platform that when people are trying to date and they will be discussing through chat or any kind of discussion, they will just use the description and upload it in the platform. And they have the project is science, it's called Science of Love. Basically, it will give you whether or not this new date you are doing is promising or not, basically, based on the chat discussion you're having. So they did the project, and they will compute an affinity score for anyone that is discussion. You just need to put this issue. So over time, they have a big data set of many people discussing and what was the outcome of the date. So they say, it would be a good idea to make a new chatbot out of this big data set that they call, the new chatbot they call Liluda, that will basically, now everyone can chat with it and ask feedback or things like that. What should be the best strategy to dating strategy, whatever. And so what happened is so now they open these models trained on top of billion of conversation. And what happened is users just try to ask questions, and they realized really quickly that the model was actually giving real world a story of other people, right? So they start like pushing the model more and more, same way like you ask the model to complete sentence, things like that. And the model end up revealing a lot of intimate conversation, cute name that people give to each other when they are dating, things like that, address, and very sensitive information. So, so this is a vulnerability, because if you train the data, if you train a model on sensitive data, then when you open the model to the world, then people can basically force it to release sensitive data as well, right? So data extraction is also really a big privacy risk to consider. The next attack is model extraction. So it's a form of extraction attack also, but here, what the attacker is trying to do is basically to steal your model. So you spend a lot of money and resource to train an AI system, and now you have your you have your API. People can pay to use it, so pay-per-use API. But the attacker here will just use few queries, and they will be able to construct a new models by using your data. So if you have heard the news recently, there are many big AI model developers that are claiming that other developers are stealing their models, things like that. So we are basically in this story. So per se, this attack is not a privacy attack in the first place, but it can be used to have a copy of the models. And when you have the model in a white box setting, that is, you have full control, you can do more powerful attacks as well. So yeah, this is a brief overview of some attacks. Now I will focus on some defense. So there are many solutions that has been considered in the recent year. So I will focus mostly on membership influence attack. So the first attack you ask. So, but there are other attacks where we have some idea how to defend, but they are not robust enough. I will say these are convincing as a solution. So data extraction, for example, the Liluda case, sometimes what people has been trying to do to reduce the risk is to do different sort of data cleansing. Basically, there has been some evidence that when you have duplicate inputs, you increase the memorization. So basically, when your model is being trained and they have seen the same sentence several times, then they memorize it more than other part of the document. So one strategy here will be to do this data cleansing and remove duplicates, but this is not giving a formal guarantee. People has already also been trying some techniques called differential privacy that I will also present for membership. This differential privacy is an efficient solution for membership, but it's really hard to implement for data extraction, specifically because of the type of model we are talking about, right? We talking about large language models. Using this method here will have a big impact on the utility. So you might have privacy, but the model will not be really useful for anyone. So and for extraction, when people are stealing your models, it's really difficult to defend. So people have been trying to more doing something like a detection. So let's say someone steal your models and they went to create a new startup and start deploying the same API. You can have some you can perform some analysis to check if this was a copy of your model or not. And we also have been seeing a recent discussion on anti-distillation strategy. Like basically, if you have seen the news recently, Claude, Anthropic, they had their open source project was released unintentionally, and people realized they have a lot of anti-distillation techniques in it. Basically, when you are discussing with the clouds or with your model will provide a reasoning trace. That is how they come up with the output. And this is what people use to do the model stealing. So what they has been trying to do is to add just a random test at the end, just do some poisoning of the output so that it will not be useful for anyone trying to steal the model. So there are some evidence that people have been trying that, and there are also some research work on it that show it has it can prevent a successful copy of your models. Okay, so for membership, that is the main attack we will be discussing when it comes to existing solution. As I was saying, the cause of the problem is overfitting. So if your model have different behavior because they are really confident on data they have seen in the training when compared to data they have never seen in the training. So a natural solution here will be just address the overfitting problem. So you can do regulation or any regularization or any strategy to help your model generalize better. But this does not give you a formal guarantee that no one will be able to perform the attacks. So to address that, there has been solution using differential privacy. So differential privacy is a privacy definition that basically say that if your system have this definition, it means its output should not be really dependent on the presence or absence of any user. So this was the strong privacy definition I was presenting previously, called undetectability. So the presence or absence of anyone should not be detected from your models. So the definition is pretty easy to understand. So don't pay too much attention to the math. What this is saying, just if you observe the output of your models in two cases, case where the person you want to protect is present and the person you want to protect is absent, normally what you are observing should be pretty much the same. So if you are able to have these kind of properties, it will be really difficult for someone observing your model output to use it to learn if someone is contribute to the data, because by definition the participation is not really something that you will observe through the output. So differential privacy gives us a way to learn from the group without focusing too much from individual specific user, and that's what make it useful to prevent the membership attacks. So the way it works generally is you will be doing some perturbation on your output. So instead of releasing your original models, you will add some perturbation on it, and it will have these properties. And there are many ways to do that. One is to do output perturbation, which is what I will present the most now. And we also have objective perturbation, objective function perturbation, and training algorithm perturbation. So but we focus mostly on output perturbation. So let's say you are training your models, you have the final models. Instead of releasing that model, you just add some noise, and this noise will make it in a way that you will protect the individual contribution of everyone. So this method to add the privacy is useful because since you are doing post-processing, you are adding the noise after the model is trained. You don't need to retrain your model because training the model can require a lot of resource. And it also does not ask you to modify your training methods. So any training method can work. And these are two concrete examples that is already implemented that you can consider. For example, first one is known as PATE. So PATE basically will assume you have a public data that is not label. You don't have any label on this public data, and you will use your private data. Let's say you are a medical institution, you have a lot of private sensitive data. Instead of training your model on your sensitive data and releasing them, you can use this data, the knowledge in this data, you can transfer it to a public data by labeling this public data using some model you train on your private data. And the way you make that process private is instead of just using your private models to label the public data, you will add some noise in the prediction they are making. And this will give you some form of guarantee that the presence or absence of a specific user is not really impacting the output of your data. So the second one is prompt PATE. It's a variant of PATE that is more useful for this new type of model we are using now. So we are all using LLM today to do prediction. And the same way you can use the private model to label public data here, so here the private information you have is the instruction you are using. So when you are using ChatGPT now to do prediction, you say, let's say, I want to do grading or something like evaluation of different application. Here are previous application with the corresponding prediction, and then use them to do the new prediction. But these prompts you are using are private by design because they contain personal data. So instead of using them, you will use your private prompt to transfer their knowledge to a public prompt that does not have any specific information. So this is one way to address it. So now I have covered the first category is you designing a model for your organization. This model is trained on private data, and you want to make sure people are not stealing anything or learning any private data. The second category is you using your AI system in your everyday life by sending your private data. So here you can also expose yourself or potentially other people to privacy risk. And the reason why this is the case is now the AI system you have are really powerful in extracting a lot of sensitive information out of something that may look not sensitive in your in the first place. So this example is this paper has been that has demonstrated that clearly, where they were showing that you can use just a normal test that people posting online, and you can use any large language model now to be able to predict sensitive attributes like age, gender, things like that. So it's now more and more clear that these models are really powerful, that they can learn a lot of information. So if in your daily interaction with AI system, you send data, let's say a meeting note or things like that, that you will assume are not really private, then it is not the case, because now it's possible to also learn this information. The second problem we have is now you are using also AI in a more agentic way, in the sense that you give the model your data and you ask the model to do a lot of things by communicating with the world, right? Sometimes it could be communicating with other AI system or communicating with other information system, like when you use your data to do tool use or to do search, things like that. You are asking your models to use data, and it has already been shown that when you do so by delegating all your data to the models, they are not really good at knowing what to share or what not to share as compared to human, right? So this also create a problem, because everyone now, I don't know who is using OpenClaw here. Okay, so this is this model, the model that are designed on top of OpenClaw, sometimes they don't know if they are oversharing your data. So it could be the case that they are connecting with other agents, where they're basically sending all your friend contact or things like that. So it could be problematic in some case. And the way we quantify this risk is to use something known as contextual integrity that was proposed by Hélène Nisbaum. Contextual integrity is a definition of privacy that defines privacy as appropriateness of sharing information or not sharing in specific context. And you can see it more clearly through an example. For example, let's say you are a passenger in a Uber, you are using Uber to do a specific trip, right? And you have a camera that is recording you for safety. So in this context, the data is sent to Uber server. So maybe you will feel confident, you will feel okay with that, because it's for your own security. But let's say your driver is streaming the same data on Twitch just to entertain his friend, things like that. Maybe you will not be really open to this use of your data. So it's the same data, but the way it's shared and it's transmitting is what makes it a privacy risk. And this is one way we can also use to quantify what are the risks when we are delegating all of our data to AI system. Just the last solution I want to discuss with today is how to do it when knowing now that when you send your data directly to a AI system like ChatGPT, maybe they can learn a lot of things on you. How can you use ChatGPT without sharing your data, right? And this is something we can do with some tool known as homomorphic encryption. So homomorphic encryption is just a property of an encryption system that make it possible to work on encrypted data without having to decrypt them. So basically, you can encrypt all your data, send it to other models, and ask them to do computation on the data and send the result, and you only will be able to learn the result. So in practice, this could help us to not sharing too much sensitive data, right? But the way it works is basically performing all the computation that you do when you are using neural network on encrypted data. But we have two main operations when we are using a neural network. We are doing some linear transformation, and we're also using some non-linear transformation. And making all these operations on encrypted data is very hard. And one way to do it is basically to make homomorphic encryption useful, you need to only use something like linear operation. So because these neural networks are not only using linear operation, you need to do some additional step. And one of them is to do some transformation of your activation, mainly to have some polynomial approximation of your models. I'm almost done. And then now it becomes easy for you to do all the prediction on encrypted data. And this is one concrete solution against that can help you use AI system to have some prediction without having to share your data. So I will briefly conclude by saying we have seen that our interaction with our AI system can create some risk, right? We also see that protecting privacy is not just about protecting the models, but also protecting how our data is shared in different contexts. So we really need a lot of work in this second aspect, because this is how most of us are using data now, and we are really sharing a lot of data through this kind of category, but it's not really clear what are the solutions now. So there is more research that are needed to address them. So yeah, we stop here. Thank you for your attention.